Your support helps us bring you programs you love. Go to wyomingpbs.org, click on Support, and become a sustaining member or an annual member. It's easy and secure. Thank you.
If you have a cell phone or a big screen TV, chances are it was manufactured with rare earth elements, which are also hugely important for national security. Think fighter jets and lasers. So why are all rare earth elements primarily mined and processed in China, especially when Wyoming has some of the highest quality rare earth element deposits in North America? Rare earth elements, next on Wyoming Chronicle.
This program was funded in part by a grant from Newman's Own Foundation, working to nourish the common good by donating all profits from Newman's Own food and beverage products to charitable organizations that seek to make the world a better place. More information is available at newmansownfoundation.org. Funding for this program is made possible in part by the Wyoming Humanities Council, helping Wyoming take a closer look at life through the humanities, thinkwy.org, and by the members of the Wyoming PBS Foundation. Thank you for your support.
And as we begin our discussion about rare earth elements, it's our pleasure to welcome to Wyoming Chronicle Scott Quillinan. Scott is the Director of Research and Communications at the University of Wyoming School of Energy Resources, and also the Director of Economic Geology Research here at the university. Scott, welcome to Wyoming Chronicle.
Craig, thank you, and it's a privilege to be here.
We have teased our audience just a little bit on where rare earth elements are used, and essentially it's in a lot of things.
Yes.
And I think people are going to be very surprised about what they are, where they come from. But essentially, Scott, I think it's important that we begin the discussion about what are they? What are rare earth elements?
Sure. So rare earth elements, if you could go back to your high school chemistry class and you could picture that row of 15 elements that's kind of removed from your periodic table, a little bit lower. We never talked about them. Nobody ever talked about them in high school chemistry. That's the lanthanide series. That's the list of rare earth elements. And it also includes yttrium and scandium. They're not actually rare.
Yeah.
So they're all over. They have a kind of relative abundance through the Earth's crust, but they only occur in high abundances in just a few locations around the world.
And as we'll talk about here in just a minute, one of those places is right here in Wyoming.
That's correct. Yep.
So, and we'll get to that. But I want to even a broader sense, Scott, is where are they used? Start the list.
Okay, well, let me say it more broadly. If you have a device that plugs in, it has rare earth elements in it. If you have a device that has a battery that you charge, it has rare earth elements. If it has a flat screen TV or screen, your smartphone, it has rare earth elements in it. If it's a glass that doesn't glare, it has rare earth elements in it. So any advanced industrial material or component, it really has a good portion of rare earth elements in them.
It's interesting to me that the United States used to be a leader in the mining and processing of rare earth elements.
Sure.
But isn't today.
It isn't, no.
Let's go there now. Why is that?
Well, now over 85% of the production comes from China. So the path they took is interesting and quite strategic. So back in the mid-'80s, they opened up and said, okay, if you are a rare earth element developer, we invite you to China to come and develop rare earth elements, and we'll even give you a rebate on the export tax. So if you're a developer, you're going to say, okay, well, I can go to China and produce rare earth elements for cheaper than I can do it here in the United States. So that brought a lot of foreign investors and a lot of foreign companies into China to open up operations. And then the next thing they did, about 5 or 6 years later, they said, okay, wait a minute, we actually view rare earth elements as a strategic mineral. And so they began to limit foreign investment and foreign involvement in the industry. So if you have your rare earth element operations in China, now all of a sudden you kind of get the dials turned on you and you're forced out just a little bit. And if you have a mine, you really had kind of two options. You could sell or you could shut shut up shop and leave. So what a lot of things or a lot of companies did is they sold to Chinese partners. And so now you brought everybody from all over the world to produce cheap rare earth elements, and then you kind of pulled the rug out on foreign involvement, so now it's a Chinese industry. And so then the next thing they did, and this happened in the late 90s, was they began to limit the export of raw rare earth element ore. So let's say you are a developer in Malaysia that likes to do a rare earth element alloy that you sell to the global markets. Now all of a sudden China is saying, okay, well, we're not going to actually export you that raw rare earth element material anymore. Now, so then what happened to global prices? They just shot up. So if you're that developer trying to get your hands on rare earth elements, you can no longer afford it. So then that kind of set the pathway for cheap domestic advanced manufacturing in China, because they could access cheap rare earth elements, and it kind of drove everybody out of the industry. And that happened in the late 90s, and it took about a decade before the rest of the world really caught on and said, hey, wait a minute, all of this is being done in China today. And now we're starting to need these elements for energy security, for national security, and we don't have them. So that's why rare earth elements are such a buzzword today.
They're used in lasers.
Correct.
They're used in bombs.
Correct.
It's a national security issue, yet
fighter jets. Yep.
Ironic to me that we're so dependent on China. The School of Energy Resources here at the University of Wyoming has a role in researching rare earth elements and perhaps re-energizing maybe its mining and maybe even manufacturing rare earth elements here in Wyoming. Is that accurate?
That's accurate, yeah. So we take a twofold approach here. The first approach is not led by me, so I'll just give them a little plug and then I'll talk about what we're doing. But the first approach is doing regulatory and policy analysis. So it's a forward-looking, forward-thinking group that's looking about, what policies need to be developed to establish a rare earth element industry, or what kind of regulatory framework might need to be developed. So that's kind of the first approach, is looking at from a policy and regulatory analysis. And then the second approach is the research approach. So we're looking at identifying where rare earth element lie today, where the resources are, how they got there, how they occur, maybe explore for additional ones, start to understand what needs to be done when you extract them. Do you need to upgrade them? Do you need to concentrate them? What can be used from how can they be used to start to spur an advanced manufacturing industry? But I would say the role of SER is really to kind of take some of that economic risk out of the industry. Like, they've got a lot of questions, so we can go in and through research, help answer some of those questions and take away some of the uncertainty.
So it turns out that Northeast Wyoming is home to one of the highest quality rare earth deposits in North America.
That's true, yeah.
So why not start the process? Let's go. Let's make the United States rare earth element independent.
Yes, let's do it. So you're referring to the Bear Lodge deposit. It's just north of Sundance, Wyoming. It's probably got about 18 million tons of rare earth elements associated with it. It's been well documented. We know it's there.
Is this privately owned? Or is it?
It's federal private, yes.
Okay. A combination?
Combination.
Okay.
Combination of the two. You get into these factors of, we have one country that owns almost all of the market, right? So it's really hard to get going. So why not just start an industry in Wyoming? Probably that's the biggest hurdle you need to get, is you need to be able to get into the market, to be able to compete economically and environmentally.
Is there any sense that the federal government has recognized that this is an important issue for national security, much less for the convenience of me having a nice cell phone with a good screen in my pocket?
Yes, I think it's upfront, and it's an issue that we know we need to deal with. I haven't seen anything in the way of subsidies to help kickstart an industry, but I think the ears are open. If there were some unique policy or regulatory actions that could be taken, I think there would be open ears to help get a domestic industry going.
I've read where in the last couple of years in the Trump administration, when they talked about a U.S.-China trade war, that the threat of withholding rare earth element exports to the United States was an issue. Do you know much about that?
I don't know much about it, but it is an issue, right? If it's a matter of national security, so you talked about lasers, but the one I like to use is the fighter jet. It has over 900 pounds of rare earth elements in an F-35 fighter jet. So from a national security perspective, we're going to need a continuous supply of rare earth elements. From an energy perspective, as we begin to electrify our transportation fleet, every one of those cars needs a steady supply of rare earth elements to keep those batteries running. So, I mean, I find it really important.
Let me tell you what I've read about the market for rare earth elements and if you can contribute any more. In 2018, the global rare earth market was about $8.1 billion. The estimate that it will be more than $14.4 billion by 2025. On this kind of path, it seems to me.
Yes, I would agree with that. I think that's absolutely true.
Let's talk about coal.
Okay.
And its potential relationship in this discussion. Turns out possibly that you can get rare earth elements from either coal or coal ash. Is that right?
That's right. Yeah, so we have a program focused exactly on that here at the School of Energy Resources. As you're right, as it turns out, Wyoming Coal has rare earth elements associated with it. And what we've been finding is they're not consistent through the whole seam. They tend to lie on like that top 2 or 3 feet between like the transition of when you would go from non-coal into coal. It's kind of an ashy coal. And then again at the bottom. So the interesting thing is that ashy coal is kind of the stuff that's scraped off and it's put back in the pit because it's not that high pure quality high BTU coal that they used to sell. So they're already mining the rare earth elements and just moving them aside and putting them back into the pit. So our program is looking at how consistent that, for lack of a better word, ore body might be in Powder River Basin coal and how laterally continuous it is between the mines. So that's what we're looking at today.
What are you learning about the timeline for research in a project like this? And then I'd like to talk to you about what it means to not only have the coal ash, but then to really extract the processing part, if you will.
Sure.
Where are you at and where is the state at relative to this?
Yeah, so you mentioned coal ash. So if you burn coal in a coal-fired power plant, at the back end you get a coal ash. And rare earth elements are concentrated in that ash. And so we do have another program that is developing a pilot project to look at the economic viability of extracting rare earth elements from coal ash. And that pilot, you mentioned timing, is going to take about 3 years, start to finish, before we have any really meaningful results on what the economics are behind it and what any environmental challenges might be behind it too. So research takes time.
Sure.
And once we have a pilot, then we've got to go to scale up and then commercialization. So you're really talking a decade.
I think that's important to the discussion when you think about Wyoming Coal and adding value
Yes.
to Wyoming Coal. It certainly shouldn't be emphasized that this is a replacement for coal as we know it today to keep the industry going at the rate it is today. Is that true?
Right. So even if tomorrow we were able to start a rare earth element mining operation, it would never be as large as our coal mining industry is. It would just never would be. So what you're leaning towards is if we mine the rare earth elements alongside coal, this gives an added value or a cost competitiveness to Wyoming Coal that can be sold to market.
One aspect about the U.S.-China relationship is it's true, I think, that even in places that do mine rare earth elements, much of that is still shipped to China
Yes.
to process
Right.
and not processed domestically. Why is that?
It's because, just as I mentioned, they were very strategic on how they built up their full supply chain. And so that's exactly what happens. Now, all of those different steps, the beneficiation, the metallurgy, the processing, all of that now happens in China. So even if we mined them here in Wyoming, we would probably put them on a boat and ship them over there for processing.
Can that potentially change? Do you see that ever becoming economically viable for Wyoming and even a major employer, so to speak, the mining and the refining, the processing, if you will, process of rare earth elements in the state?
Yes, that's the carrot for the industry here. What we want to develop is that full supply chain domestically, and we'd like to do it here in Wyoming, where you mine it, you enrich it, you do it through beneficiation, and you begin the advanced manufacturing here.
There are regulatory concerns, and there are likely environmental concerns. Let's take the regulatory concerns first. What are the hurdles?
Well, you have to permit a mine. That's not an easy step to do. I don't think we know what the permitting hurdles are for co-mining rare earth elements with coal. I think that is probably a little bit easier pathway.
I mean, it seems to me you're extracting the coal. There it is.
Right.
Is that too simplistic of a view?
It's probably a little simplistic, but I think you could go in and kind of tweak existing permits and regulations and make it acceptable. So I see that as a path of least resistance.
What about the environmental concerns, either with trying to capture rare earth elements from coal or coal ash, or even from new rare earth element mines, if you will?
Any time you're going to mine, process anything, it has to be environmentally friendly or environmentally acceptable, right? And that's what we do here in the U.S. is you put those regulatory frameworks together to protect against our environment. And so there are hurdles, but I don't see they're unsurmountable.
Thorium is a byproduct potentially.
Can be, yes.
Which is radioactive,
right?
For example. Are there other environmental concerns that are top of mind to you?
So you bring up thorium. Thorium is in traditional deposits like the Bear Lodge. It does contain thorium, so you do have to deal with radioactivity. Some of the unconventional deposits like coal, and we're looking at phosphates, a lot of those don't have thorium, so it's not as big a deal.
Are there other states in the country that are getting into this, that are recognized, like Wyoming, that either this is a national security issue, we need to step up here, and we have opportunities to do so?
Absolutely. So rare earth elements, it's the new buzzword, and if you're a fossil energy economy like Wyoming, and they've put together dollars to work on rare earth elements and coal, you're interested.
So
right?
Kentucky, Pennsylvania,
West Virginia. West Virginia is also looking at acid mine drainage as a way to mine rare earth elements. The Mountain Pass mine in California, they produce about 15% of the global rare earth element production just in the last couple of years. There's the Round Top mine in Texas and Alaska. So there's potential here. It just needs a kickstart.
Is this a race, or is this a matter of needing to be all hands on deck to bring the United States to rare earth element independence, if you will? So
there's a race between states, but there's also an opportunity to team and collaborate and get things done from a national level to move these industries forward.
Scott, what has the state of Wyoming done to support this effort?
So through the School of Energy Resources, we've supported some seed funding programs to begin the rare earth element research, the policy analysis. We do have a very mine-friendly state. So for the folks that are developing the Bear Lodge deposit, I think the legal framework exists for them to pursue that project. I think there's opportunity to work with local economic development groups to develop some of the frameworks locally and public acceptance that could be done locally to help kickstart some of these industries. We haven't invested many dollars in a research program, for example. Most of those dollars come from the federal government. So I do think there's an opportunity, trying times for the state of Wyoming, but I do think there's an opportunity for investment in research, both in exploration and extraction of rare earth elements.
Do we know whether the American Rescue Plan, as we're learning more about each and every moment, might be helpful here through dollars from maybe the Department of Energy, for example?
Yeah, so there are several funding programs offered through the Department of Energy to help get those dollars out and into research, and so we do have a couple of pending proposals. Hopefully, if those are funded, that those will give us some dollars to help kickstart some of this.
You had a crystal ball,
Yeah.
and everything went nice and smoothly in that crystal ball. When might Wyoming, in a good case, see extraction of rare earth elements in northeast Wyoming, do you think?
I think they could see it within 5 to 7 years. In northeast Wyoming, the research has kind of already been done. The resource is known. They were just funded recently on a pilot to see if they can extract the rare earth elements from that deposit. So probably more on the 7-year time frame, but it's, as you know, you can easily get to 10 pretty quickly.
Senator Joe Manchin, along with others, Lisa Murkowski and Senator Capito, have introduced the Rare Earth Element Advanced Coal Technologies Act.
Yeah.
Is that important? And is it important that that be considered sooner rather than later?
It's extremely important. Like I said, without it, there just really isn't any research dollars to help support this effort. I think maybe the most important thing they did is trying to extend it for 10 years. So that gives you a consistent dollar amount every year to kind of incrementally grow this.
Is this a priority of the Biden administration, do you think?
I think it's bipartisan. I really do. I think from a national security standpoint, from a energy security standpoint, I think it's a bipartisan issue.
What if China comes and undercuts again anything that the United States or Wyoming tries to do?
Any resource commodity is going to be subject to global market forces. And you can't insulate against that very easily. So I have no doubt that starting an industry is going to be really tough when you have operators out there that have been doing it for a really long time and control the whole market. So some things that we've thought about here domestically is setting up maybe some standards, some environmental standards, maybe some labor standards that allow companies to purchase rare earth elements. Let's just say domestically we could produce a rare earth element and we could do it to a certain environmental standard. We could show that it's done under ethical labor markets, and we could put a little stamp on it. And that would allow your Apples or your Teslas or your other big companies the ability to buy a certified product. I think that's something that could help kickstart a domestic industry.
Do you also believe that this will be an industry that will need to be subsidized or directly supported by the United States government to fulfill its need to, have the elements needed for national security and for other uses?
I don't see it going really without some sort of help, right? The market forces are just too difficult right now.
What's going on with lithium in Wyoming? Because there is lithium in Wyoming.
Sure, so you can expand rare earth elements to include critical minerals. Lithium is definitely a critical mineral. It's one of those battery minerals, just like nickel and cobalt. We do have lithium in Wyoming. It's mostly associated with water that's co-produced with oil and gas. So we've done a little bit of research on that. We found...
So the question is there rare earth elements in water used for oil and gas production?
There is. But a strict rare earth element, we found them only in the parts per trillion level. We found them in every water we sampled, but
not viable then.
Just very, very minimal amounts.
How about lithium?
But lithium, we can find it in about 100 parts per million. So depending on the extraction technologies, and again, is it a value added to oil and gas production, or does it need to be a standalone? 100 parts per million is probably iffy from an economical standpoint.
Scott, if I'm a student here at the University of Wyoming, what field of research would I get into where I could be hands-on with some of the research that's happening right here?
Sure, so we work a lot with the geology department, so they're economic geologists over there. We work a lot with the chemical engineering and the engineering department, so if you're an engineering student, you would fit right in with the rare earth element research program. We work a lot with the business college and the law college and physics.
So just to tie things up, Scott, where do you see the university itself going in this research? Is it plateaued now? Is there a lot more to do that the university has to be aggressive in, so to speak, in chasing? What will the university's role be here in the next 5 to 6 years, would you say?
We're accelerating. So there's a lot more federal research dollars being made available. So we'll be competing for those. And what we really want to do is move stuff out of the lab and into the field for pilot testing.
Well, Scott, it's been a pleasure. Certainly it's an area I think that's lesser known in Wyoming, but couldn't be more important to our country, and quite frankly, even the world. So it'll be interesting to see where this goes.
Yes, thank you for having me. It's a very exciting industry, and I see tremendous growth in it over the next couple of years.
And thank you for your time and for joining us on Wyoming Chronicle.
Yes, thank you.
This program was funded in part by a grant from Newman's Own Foundation, working to nourish the common good by donating all profits from Newman's own food and beverage products to charitable organizations that seek to make the world a better place. More information is available at newmansownfoundation.org. Funding for this program is made possible in part by the Wyoming Humanities Council, helping Wyoming take a closer look at life through the humanities, thinkwy.org, and by the members of the Wyoming PBS Foundation. Thank you for your support.